Welcome. In this presentation, we will explore the principles for designing effective relational databases. Get ready to dive into the world of structured data. Relational database design is the process of creating a database structure that efficiently stores and organizes data. It's based on the relational model introduced by E.F. Codd, and it focuses on the relationships between different data entities. The primary aim is to minimize redundancy while ensuring data integrity. Here is a diagram illustrating the relationships between customers, orders, and order items. Let's cover some fundamental concepts in relational database design. First, we have tables or relations, which are two-dimensional structures that store data in rows and columns, representing entities or concepts in the database. Then we have attributes or columns. These are specific properties or characteristics of an entity that are stored in the database as columns in a table. Tuples or rows are individual records in a table, representing specific instances of the entity with values for each attribute. And finally, relationships are logical connections between tables that represent how entities interact with each other in the real world. Keys play a crucial role in relational database design. There are different types of keys. The primary key uniquely identifies each record in a table. The foreign key creates relationships between tables by referencing primary keys. The candidate key is an attribute or attributes that could potentially serve as a primary key. And finally, the composite key is multiple attributes combined to form a unique identifier. Here is a diagram illustrating the use of keys in students, courses, and enrollments tables. Cardinality defines the types of relationships between tables. There are mainly three types of cardinality relationships. One-to-one, where each record in table A relates to exactly one record in table B. One-to-many, where each record in table A relates to multiple records in table B. And many-to-many, where multiple records in table A relate to multiple records in table B, which typically requires a junction table to manage the relationship. Here are illustrations of the relationships between person and passport, department and employee, and student and course tables. Normalization is a systematic way of ensuring that a database structure is suitable for general-purpose querying and free of certain undesirable characteristics, such as data redundancy and update anomalies. Key normal forms are first normal form, second normal form, and third normal form. First normal form ensures that each table cell contains a single value, each column has a unique name, and no repeating groups of columns. Second normal form builds on the first normal form. All non-key attributes are fully functionally dependent on the primary key. Third normal form builds on the second normal form. No transitive dependencies, meaning non-key attributes depend only on the primary key. When designing a database, there are some best practices that should be taken into consideration. Atomicity means storing atomic values that cannot be further divided. Minimize redundancy. Avoid storing the same data in multiple places. Data integrity. Enforce constraints to maintain accurate data. And performance. Design with query optimization in mind. This is an example of a good table design. It's crucial to avoid common design pitfalls to ensure a robust and efficient database. Some common issues to avoid are poor naming conventions, so use clear, consistent naming for tables and columns. Inadequate indexing. Missing indexes on frequently queried columns can severely impact performance. Ignoring data types. Using inappropriate data types wastes storage and affects performance. Denormalization without purpose. Only denormalize when there's a clear performance benefit. Here is an example of poor design versus a better approach. In summary, a well-designed relational database provides a solid foundation for applications, ensuring data integrity and efficient operations. Proper normalization reduces redundancy, minimizes anomalies, and creates a more flexible database structure. Understanding and implementing appropriate relationships between entities is crucial for accurate data representation. Good database design is not about perfection, but about making informed trade-offs between normalization, performance, and practical requirements. A well-designed database evolves with your application while maintaining data integrity. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.